completing the square, okay? So in this case, what we have is we have a function, all right? Let me change this to this one. Okay, so we have a function, f of x, and let's see, it's ax squared plus bx plus c, okay? And what we're gonna do is we're gonna put this in our, what we call our vertex form, which is a times x minus h, quantity squared plus k, okay? Now, there's a couple things I want you to understand. The cool thing about this is from here to here, this has a binomial square. There's only one x, right? So what we need to do is we need to create a perfect square trinomial. Now, the thing that I always like, I think, like we can always teach this of like, do this, then do this, then do this, right? But what happens? Most students forget the whole reason of what they're doing, why they're doing it, and how to do it. So the main thing I want you to understand is like, or the beauty of completing the square is understanding perfect square trinomials, right? So let's just kind of go through a general one, like x squared plus 6x plus 9, okay? This is a perfect square trinomial. What two numbers multiply to give you 9, add to give you 6? Hopefully you recognize, like, hey, that is a 3 and a 3, right? So x plus 3 times an x plus 3, which is the exact same number, right? So which can be written as an x plus 3 quantity squared. Again, that relationship of going from standard form to a binomial squared is exactly what we're looking to trying to achieve, right? We're trying to create this perfect square trinomial because then it can be factored down to a binomial squared, which is going to put us into this form. So if you look at this equation, f of x equals a 3x squared plus 5x minus 4. Is that the same thing as like this? Is that a perfect square trinomial? And unfortunately, no. I kind of wrote that really fast, so let me just rewrite it a little bit slower, make it nice, a little bit neater. So what we need to do then is we need to create a perfect square trinomial with that information. So I have an f of x equals, let's say a 3x squared plus 5x, there you go, minus 4. Okay, so how do we create a perfect square trinomial? Well, the first thing we want to remember is when we're trying to create a perfect square trinomial, we cannot have a number in front of our x, right? So actually what we need to do is factor that number out. Now, I'm assuming that's probably one of the reasons where this problem gets kind of confusing because there's a couple different ways to go about this. The way that I'm going to teach it this way is I'm just going to factor out the first two terms. I'm not going to worry about the constant. I'm just going to try to create a perfect square trinomial with the x's, okay? So when I factor out a 3, what I need to do is I'm getting rid of the 3, right? So I'm basically dividing out a 3 from the first two terms. That's going to leave me with a x squared plus a 5/3 x minus 4. All right. So again, notice I didn't do anything with the 4. I just factored the 3 out of there. Now, this is what I'm going to want to do is create my perfect square trinomial. Now, the thing I want you to understand about this perfect square trinomial is notice the relationship between the 6, which is our middle term, and our constant, right? So what happens is how do you go from 6 to 9? Like, how can I do that? And you might be like, well, you add 3. Well, yeah, you could add 3, but that's not going to work for all, that doesn't work for all numbers. Like, how can I consistently go from whatever my middle term is to find my last term, right? And that's going to create always a perfect square trinomial. And it just can't be add 3, right? You could do this with like 4s or 5s. Like what is it we can do to go from given our middle term to find that last term? And what we do is we call that number like c, okay? So we say like x squared plus a 5/3 x plus c minus 4. So how do we obtain this value c? How do we get that? Well, what you're simply going to do, or what the rule is, like c is equal to a b divided by 2 quantity squared. That's how you can always find the c. So in this case, what I'm simply going to do is I'm going to take a 5/3 divided by 2 and then quantity squared. Well, what is 5/3 divided by 2? Well, hopefully you recognize here that is going to be a 5/6 squared, which is going to be a 25/36. So therefore I have a 3 equals a x squared plus a 5/3 plus, and this is going to be a 25/36. Okay, now this is where things start to get a little confusing because what I want you to understand is when I factored out the 3, all right, when I factor out the 3 here, I didn't really change anything on this side of the equation. I just factored out the 3. However, when I add a 25/36 here on this right-hand side, you just can't randomly add a number, right? So whatever you add a number, if you want to keep this equation pure, you're going to have to subtract the number. So I need to subtract a 25/36. But things just got to leave in a little bit worse because I am actually not adding a 35 or a 25/36. What I'm doing is when you look at this parenthesis over here, no, where's that going to go? Okay, that's going to go to the 5. What's happened? Oh, shoot. Okay, let me just rewrite this. So that's a 25. So it's going to be minus a 4. That's going to be minus a 25 over 36. So what I want you to understand is, because of distributed property, there's a 3 that's being multiplied by the 25 over 36, right? The 3 is actually multiplied by everything inside that expression. So over here, I actually need to multiply this by a 3 as well. So therefore, now this is going to become a perfect square trinomial, okay? Just like we did over here, like why was this so important? Again, I can go from perfect square trinomial, I can go from a binomial squared down to, or I'm sorry, a perfect square trinomial down to a binomial squared. So the confusing thing is, well, how do you factor that? How do you factor that down? And I did forget an x. Let me put that x there. So the cool thing is, if you want to find that h, all h is b divided by 2. Okay, now I'm going to say plus or minus because, again, if we have a positive, we want to make sure the b, our h is positive. If our middle term is negative, then we want our h to be negative. So what was our b divided by 2? Our b divided by 2 was 5 over 6. So yeah, you could try to like factor this and think about it, but again, like here, it's really easy. X plus a 5 over 6. Now let's go and check our work, okay? So, and then again, it's a 5 over 6 squared. 5 times 6 times 5 or 5 times 6 is going to be 25 over 36. That is good. And hello, Nee. And then 5 plus 5 over 6 plus 5 over 6 is going to be a 10 over 6, right? Which again, divided by 2 on top and the bottom is going to be a 5/3. So it works out. Now over here, we have some work to do. So I have a minus a 4. And then over here, I can divide this out. I can divide a 3 into the top and bottom. So that's going to be a 1. Divide a 3 into the denominator. That'd be that's not going to be a 9. What am I doing? That's going to be a 12, right? So 1 over 12. That's a 1 over 12, right? So it's a minus 4 minus a 25 over a 12. Divided 3 in the top and the bottom. Okay, so now I just got to combine these two, right? And hey, Jan and K Carl. So then what I'll do is I'll put a 1 over here, right? And then basically I need to multiply that by a 12 over 12. So it's like, because I got to get common denominators. Man, this is a good problem. 3 times an x plus a 5 over 6, quantity squared. And then this is going to be minus a 12 over 12 minus a 25 over 12. Now they have common denominators, so now I can go and subtract them. If you owe me $12 and you borrow $25 more, you now owe me a $37, right? And again, that's all going to be divided by 12. So this is 3 times a x plus a 5 over 6, quantity squared minus a 37 over 12, assuming I didn't make any mistakes. My vertex now is going to be a negative 5 over 6, comma, a 37, negative 37 over a 12.